class I know it starts at 11, when is it let out?
Usually, you leave whenever you need to leave. Okay, so if you need to go somewhere at 11:30, typically we're done no later than 10 till. So no later than 11:15. Okay. Yeah, but sometimes students have something else they have to do, and you just kind of get up and walk out quietly.
It is okay. I'm just checking so that way I can find out a good maximized time because right now the only thing I can get lunch later and there's going to be a pizza party at Navy or that's at 6:30 and library doesn't close at 5 till today, so I'm good right now.
Good.
I believe I know this one. Distributed method.
Yes, you will start with the distributed method.
Isn't there also something called a copying method and associative method?
Those are properties. But yes. Okay, so I am gonna do this one. So I definitely want you to try them first, and then I will work them out after you have tried them. So we are going to use the distributive property here. We are going to do that. Now, this minus sign sometimes gives students a little bit of a fit. Okay? Think of that as -1 if you have to. You've got to distribute that negative. It's super, super important that you distribute that negative. So I'm going to start distributing my 2. So I have 2 times 2x. Okay, 2 times 2x, that's 4x. 2 times 1 is 2. Okay? Now, I am distributing my -1. So -1 times x is -1x. Students typically get that right. It's the -1 times the -4. What's -1 times -4? Positive 4. That's what students will often miss, is that right there. Okay? Now I'm going to distribute my 4. 4 times x, 4x, 4 times 5. Students tend to not have as much trouble when we're distributing positives. It's those negatives that sometimes make students a little bit more confused. Now, the next thing that I'm going to do is I'm going to combine like terms on the same side of the equation. So here is a like term, and here is a like term, 4x and -1. 2 and 4 are like terms. 4x minus 1x is 3x. 2 and 4 is 6. Okay? Then I have 4x plus 20. Okay? I'm going to focus on moving my 4x to the left, okay? Because that's going to be important, like we talked about with inequalities, moving that 4x to the left. So I have minus 4x minus 4x. So I have -1x plus 6 equals 20. Okay? Now I am going to move my 6 over. So I have -1x equals positive 14. And my last step then is to divide by -1. So my final answer here is x equals -14. Okay? Okay, I'm going to move to the next screen. So our next problem that we're going to do is 2 times 3n minus 4 plus 3 times 2n minus 3 equals -2 times n plus 5. What's the first thing you got to do? Distribute. Okay, I'm going to give you 3 minutes on this one. Okay. What did I do first? What did I do first?
We do distributed.
Distributed property. Good. I'm going to do that again. So 2 times 3n.
6n.
Good. 2 times -4.
Negative.
Perfect. Okay. Here I've got 3. 3 times 2n. Excellent. 3 times -3. Good. Great job. Now we are distributing a negative. This negative isn't as difficult to remember to distribute because it's not a subtraction sign. It's a negative sign. And so students typically do okay with that. It's when you've got binomials subtracted from each other, that's when students forget the negative. So this is -2 times n, which is -2n. What's -2 times 5? Excellent. Okay. Now I am going to combine like terms. I am going to combine like terms. What do I have on the left-hand side to be combined? Okay. So I have 6n, and what else? Another 6n. Good. And Terrence, what were you going to say, the other one? Perfect. Okay. So those are all like terms, and we've got to deal with like terms that are on the same side of the equation before we start worrying about a term that's on the other side. Okay, so 6n plus 6n is 12n, and I'll confess, when I saw that 6n and that 6n, I almost canceled it out to be 0. Like I almost looked at that and was like, oh, that's, yeah, I mean, we just assumed that it was going to be positive 6n and negative 6n. It sounds like at least 3 of us almost did that. But they're both positive. Okay, so that's where we get our 12n. Negative 8 and negative 9. This is negative 17. Because 2 negative numbers added together give us a negative number, and we add their absolute values. Okay? Then I deal with this negative 2n on the other side. So sometimes students will see this negative 2n over here, and they're immediately going to want to deal with that. Always combine like terms on the same side first, because it makes it a simpler problem to deal with. Okay, so now I'm going to add 2n to both sides, and I'm getting in that habit of moving my variable to the left. So I end up with 14n minus 17 equals negative 10. Okay. Now I add 17 to both sides. I have 14n. Okay, now I want to talk a little bit about what's happening here. I have a negative number. I am adding that to a positive number. So I've got to think about my addition rules for positive and negative numbers. When they have a different sign, how do I decide if it's positive or negative?
Yeah, bigger number usually dominates
Good.
the outcome.
Well, and it does, but I'm going to change your terminology just very slightly. Yes, it's the bigger absolute value. And I know I'm a little bit picky about that. The reason is all positive numbers are greater than negative numbers. Remember the number line today in class? Positive 1 is bigger than negative 10. But if I was adding those two together, what sign would I take? The negative 10, okay? So here, the positive number has our greater absolute value. So my answer is going to be positive. Now, what do I do with the 10 and the 17? Yes, excellent, Terrence, excellent. So it's positive 7. So you subtract that. And that,
It's a 7.
I'm sorry?
That gets us 7, right?
Yes, it is.
So the answer would be n equals 2?
No, it's not n equals 2. If I had 14 over 7, it would be n equals 2. It's 1/2. Yeah. Yes. So this simplifies to 1/2. So my answer here is 1/2. Good job. Okay, now we're going to do some fraction. Okay, can I move off the screen? Okay. So I'm going to get you started on this one. So I've got x plus 6 over 5 plus x minus 1 over 4 equals 2. Now, anytime we deal with numbers in the denominator, we want to get rid of those. And I'm allowed to get rid of those because I have an equal sign. Okay? That's why I'm allowed. So first thing is I want you to tell me, what is my LCD between 5 and 4? Now this 2 is just over 1, so I don't have to worry about that one as much. What's my LCD between those? 20. Good. Okay? So I want us to multiply everything times 20 over 1. And I'm going to do this first step, then I'm going to let you loose. Okay? So I've got 20 over 1, and I am multiplying that times x plus 6. Go ahead and get in the habit of putting that binomial in parentheses. Then I have 20 over 1 times x minus 1 over 4 equals 20 over 1 times 2 over 1. Now, I'm going to give you about 20 seconds, and what I want you to do is the cross canceling. That's what I want you to do next. So you're going to look at the 20 and the 5, the 20 and the 4, and the 20 and the 1.
Can you just
32. Yeah, you're absolutely right.
Can I say the answer for one?
Yeah.
Will it be 4 times 6?
You got it. That's exactly right. Yeah, okay. And I'll go ahead and do these now. 5 goes into 5 one time. 5 goes into 20 4 times. So our first expression becomes 4 times x plus 6. Good job, Terrence. Okay, anybody want to try the next one? Okay.
4 goes into 4 once, and 4 can go to 25 times.
Perfect. So then we have 5x minus 1. Now, on our last part, nothing cancels. So what do I do with the 20 and the 2? Multiply them together. Absolutely. Okay. Now, this is a problem you know how to solve. So I'm going to give you about 2 minutes to solve this. Okay, I've got to distribute first. 4 times x is 4x. 4 times 6 is 24. Okay, that distribution is why it's important to go ahead and put these things in parentheses when you got it. Okay, 5 times x is 5x. 5 times negative 1 is negative 5 equals 40. 4x times 5x, or I'm sorry, 4x plus 5x gives me 9x. 24 minus 5. So we're going to say 24 plus negative 5. Which has the greater absolute value? Good, so my answer is going to be positive. I subtract. Good, excellent, excellent. Okay, so I've got plus 19 equals 40. I subtract 19 from both sides. Okay, I get 9x equals positive 21. And I divide both sides by 9. So you are tempted to say that your answer is 21 over 9. However, what goes into both of those? 3. So my answer is x equals 7 over 3. Now, students will say, but Alicia, you said we didn't have to simplify an improper fraction, okay? You said we could leave it as 21 over 9. You can leave it as 7 over 3. So 7 over 3 is an improper fraction because you've got a bigger number over a smaller number, okay? But 21 over 9 does still need to be simplified. Because 3 goes into both of those, you still need to simplify that. Okay? Okay. Now, I'm going to let you try another one on your own. Oh, 4 times 6.
Okay.
Do you see? So I've got 4 times x is 4x. 4 times 6 is 24. Okay, let's try the next one. Okay, and I'm going to go ahead and tell you the answer to this is very ugly. It's a very awkward fraction. So I'm just going to tell you that from the beginning. So don't think you're wrong if you get an awkward fraction. So I have 2x plus 1 over 3 plus 3x minus 1 over 5 equals 1 over 10. Okay, so I'm going to give you 3 minutes, and I may move it to 4 if you guys are still working. Okay, I'm going to start talking because sometimes if you mess up early on this, it kind of throws off everything else. The first thing that we have to decide is what's our LCD. Now, some students may be able to look at that and say, oh, well, 3 times 5 is 15, but 10 doesn't go into that, but 30 does. So some students can look at that.
Lowest common denominator?
Yes.
And I got 30 because I know that's what all 3 of those go into, like 3 go to 32 times.
Right.
Go to 36 times, and 10 go to 33 times.
Right. So that's our LCD. If you can't figure out what the LCD is, I would get your biggest number, and in this situation it's 10, and I would start writing multiples of 10. Okay? Just start writing multiples of the biggest one. Okay? And then as you look at these, you might be like, oh, 30. So if you get stuck, that's what I would do. Start writing down multiples of your largest number. The other thing that you can do, but it's not at all efficient, is multiply them all together. 3 times 5 is 15, and 15 times 10 is 150. That is a common denominator, but it's really ugly. Really ugly. So it's better to look at your multiples and then go. Question?
I was asked what the answer was.
Oh, the answer, what'd you get?
I got x equals -3/4.
It is negative. but it's a little nastier than 3/4. The answer is -1/38. I know. Yeah, we'll get there. It's ugly. It's ugly. Okay? So I want you guys to try and find, if you didn't get that, I want you to try and find your mistake then. So I'm going to multiply everything times 30/1. 30/1. Okay, so I have 30/1 times, and I'm going ahead and putting it in parentheses, 2x plus 1/3 plus 30/1 times 3x minus 1/5 equals 30/1 times 1/10. Okay? Now, 3 goes into 3 one time, 3 goes into 30 10. So I have 10 times 2x plus 1. 5 goes into 5 one time, 5 goes into 30 6 times. Okay? 10 goes into 10 one time, 10 goes into 30 3 times. Okay, so what we want to do after we've multiplied everything out is we want to have completely eliminated our denominators, because it's much easier to deal with when we don't have those denominators. Okay, 10 times 2x is 20x. 10 times 1 is 10. 6 times 3x is 18x. 6 times -1 is -6. Okay? 20x and 18x, that's where we get our 38 from. Okay? 10 and -6, that gives me +4. I subtract 4 from both sides. Okay? And students sometimes will say the answer is -38. Just be careful there, because the 38 is with the x. So you've got to divide both sides by that. Okay?
I want to get how you got 1/38.
Okay. So are you with me here?
Yeah, I got
Okay.
all of that.
Okay.
I thought you were just bringing out like the 3 and the -4, like.
So 3 plus -4, that's -1. So we're still adding.
Okay, I know what I mean. I know.
You're good? Okay, got it. Okay. Now, the next one is probably one of the more difficult ones. Okay? So for this one, I only want you to multiply by the LCD first. 5x, whoops, that's not right. 5x plus 6 over 2 plus 3x, have a good afternoon, 3x minus 1 over 5. Oh, no, that's the one we just did, right? Or that's half of the one we just did and half of the next one. I do that all the time. Okay, so 5x plus 6 over 2 minus x minus 4 over 3 equals 5 over 6. Okay, I want you to tell me 2 things. I want you to think about it for 20 seconds. 2 things. What do I need to do with the subtraction sign? What's my LCD? Okay, my LCD is 6. You are correct. My LCD is 6. Change it to what? Good. And then where do I move it?
Okay, why would you change it to 5?
Okay, so if I have 4 minus 8, that's the same thing as 4 plus -8. Okay? When you've got the minus sign right here, it gets lost. we forget to deal with it. So the first thing that we want to do is we want to be sure we deal with it. So we take that minus, we make this plus, and we move that negative to the numerator. Okay? So leave that negative there so you can see it. Now what I want you to do, and I'm going to give you 30 seconds to do this, is I want you to multiply everything times 6 over 1. 6 over 1. Okay, I want to do this step so we make sure we're on the right track. 6 over 1 times 5x plus 6. Keep that in parentheses. It keeps you honest. Plus 6 over 1 times negative 1. Okay, that negative, it's just like a negative 1. So you can distribute it the same way you would distribute a negative 1. You just don't want to lose that negative. Okay, and then I've got 6 over 1. Okay, now I'm going to cross cancel and then I'm going to let you go again. Okay, 2 goes into 2 one time. 2 goes into 6 3 times. So I have 3 times 5x plus 6. 3 goes into 3 one time. 3 goes into 6 2 times. What's 2 times negative 1? Negative 2. That's the tricky thing for students, is dealing with that negative sign. Okay? These 6's cancel, and I'm left with 5. Now you guys know how to solve that. So take a minute or two and solve that. Okay, hopefully we're getting pretty good at these at this point. 3 times 5x is 15x. 3 times 6 is 18. We're distributing a negative, and this is the type of problem where students forget their negatives. Okay, negative 2x plus 8. So negative 2 times x is negative 2x. Negative 2 times negative 8 is plus 8. Okay. So what did you get there? Did you get minus 8?
Yeah.
Okay, so you've got to take that negative 2. That negative 2 has got to be distributed to both. Negative 2 times x and negative 2 times negative 4. Okay, so I think you're just dropping your negative sign. 15x and negative 2x is 13x. 8 and 8 or 18 and 8, I'm sorry, is that 26?
Yes.
Okay, I subtract 26. And so my final answer is x equals negative 21 over 13. Those are typically the most challenging. I'm going to do one with decimals just so you can see it, but that's typically not where students struggle. I'm feeling a little queasy. Is it hot in here? Is it just me? But I'm going to sit down to do this. Okay? So, our next one is going to have a decimal in it. Okay, so I have 0.4 or 4/10 times t minus 6 equals 0.3 or 3/10 times 2t plus 5. Now, students get a little bit confused with this because of the parentheses. But the first thing that I want you to do is I want you to look at this number and this number. How many decimal spaces do those have? 1. So what I'm going to do is I'm going to multiply everything by 10 because I have 1 decimal space. What if I had 2 decimal spaces? It would be 100. Good. So I'm going to multiply 10 times 0.4. And that 0.4 is already being multiplied times 10t minus 6. Then I'm going to say 10 times 0.3, and that 0.3 is already being multiplied by 2t plus 5. Now, think back to if I have 2 times 3 times 4. What's 2 times 3? 6. And once I multiply the 2 times 3 together, I'm done with both of those. And then I multiply it times 4. So I am going to multiply 10 times 0.4. What's 10 times 0.4? It moves the decimal over 1 spot. Good. It's just 4. It's not 40. It's just 4. But good. If I was multiplying by 100, then you would move it 2 spaces. So now that I've multiplied these 2 numbers together, the 10 and the 4/10, or the 10 and the 0.4, I'm done with those. Now I just deal with the 4 times the t minus 6. Okay? The same is true here. 10 times 0.3, or 10 times 3/10, I move my decimal over 1 spot. And when I do that, I've dealt with the 10 times 0.3. So it's 3 times 2t plus 5. Okay? We know how to solve this at this point. 4 times t is 4t. 4 times negative 6 is negative 24. 3 times 2t is 6t. 3 times 5 is 15. Okay. I'm going to move my variable to the left because that's an excellent habit to get into. So I have negative 2t minus 24 equals 15. I add 24 to both sides. Negative 2t equals 39. So my final answer is t equals negative 39 over 2.
Okay, so since you're like separated, you wouldn't like do the like turn thing.
Say that one more time.
Since you're like separated by like the equal sign, you would do the like turn.
Correct. Because they're not on the same side. You're absolutely right. Good job. Terrence?
It would be -2 instead of 2.
Oh, I've got my negative right here. You probably, it's on top of a word. Do you see my negative right there?
Oh.
Yeah. It's got that created with Doceri, and sometimes I lose stuff in there. But if you had written down 39 over -2, you would have been correct too. Either way, you can have your negative sign in the top. You can have your negative sign right in front of it, which is typically when I get an answer how I write it. And I'm still in that word, those words over there. Or you can write it in the bottom. All of those are correct. Okay? Okay.